going to talk on innovations in battery technologies for electric vehicles, but also equally important for the grid. I'll start by giving you just quick introduction to what is happening in electric vehicles and what actually is happening in battery. So next slide. So why is there so much interest in electric vehicles? One of the prime reason is that our air quality is very, very poor. We have 14 of the 20 most polluted cities in the world. And at the same time, our import bill for oil has been going up and up and up. Please keep moving the slide. Next. Yeah. The other reason is the electric vehicle is 4 times as energy efficient as internal combustion engine and has about 50 times less moving parts. The internal ICE efficiency is 22 to 23%, whereas EV motor energy efficiency is close to 90%. And this will get us rid of oil imports also. That's the reason there's a huge interest in electric vehicle in India and in the world. Next slide, please. Can I control my slides? Okay. No. Okay, I think we have gone previous slide. If you allow me to go. Yeah. What is the biggest bottleneck for electric vehicles? The biggest bottleneck is storage of energy for electric vehicles. Now, basically, in a petrol vehicle, there is a petrol tank, and petrol is filled, and that's what contains the energy. In this case, the battery replaces the petrol tank. And if you look at this, even though the electric vehicle is 4 times higher energy efficiency as compared to internal combustion engine, even after that, the weight of the battery is 10 to 12 times higher per kilometer of drive as compared to the filled petrol tank. Its size is 5 to 6 times higher, and cost is much, much higher than empty petrol tank. So if you really look at it from a point of view, the batteries actually have very, very small energy efficiency, both in terms of kilowatt hour per liter, in terms of volume, or in terms of weight, kilowatt hour per kg. Whereas diesel and petrol are way up here, about 8 to 10 times higher. So this is the biggest challenge. How do we really go about handling that? Next slide. So what are the battery options? Next slide, please. So basically, if you look at the battery options, first thing that we should look at, what are the parameters that we really need to worry about when we try to look at the battery and select a battery. The most important thing is, what is the cost of a battery per kilometer of my drive? If I'm using it for electric vehicles, what will be the cost? And that will be dependent on a whole lot of parameters. First of all, battery will be a capital cost, huge capital cost. Battery, the empty battery itself will have a huge capital cost. Now, the second very important parameter will be what's called specific energy density in terms of watt hour per kg. This will determine the total weight of my battery. How many watt hour or kilowatt hour of energy can I really store? And that will determine the distance that I will be able to travel. So this is a very important parameter. Equally important is volume energy density, watt hour per liter, because that will determine the size of my battery, and my vehicle size will have to accommodate the battery. A very, very important parameter is life cycles of a battery, because a battery does not last forever. Its life will keep on deteriorating as it is used, and depending on the kind of battery, either with 500 to 700 cycles or 1500 cycle or with 3000 cycles, the battery will become pretty much useless and it has to be replaced by another battery. And of course, the life cycles not just depend on the charging rate and discharging rate, but the temperature at which you do the operation. For example, in India, you will operate at 45 degrees centigrade. That will always be a problem. And what is a parameter called depth of discharge? Um, the battery is also chosen, taking into account the capacity and depth of discharge usable, the C rate, the charging and discharging rate, and safety and safe disposal. So battery is selected to match vehicle requirement in terms of energy required to travel a certain range, influencing battery size. In terms of instantaneous power requirement, as I pointed out, weight and size, capital costs and life cycle, time to charge, and safety and safe disposal. Next slide, please. So what are the what are the ask of the battery? When you select a battery, what are you looking for? The first thing that you look at, high specific energy, long runtime in most appliances, in this case, electric vehicles, high specific power. So you should be able to draw out more power when required. For example, when you're accelerating or when you're climbing a slope, you should be able to draw out larger power. Affordable price always plays the very, very important role in a battery. The long life, the longer the life is, my replacement time will go. Otherwise, I'll have to depreciate the battery for every cycle, and I have to worry about whether I have to replace the battery in 2 years, 3 years, 4 years, 5 years. Safety is a very critical parameter, and this lithium ion battery is very safe, and yet you have to use it carefully. It can also become very unsafe. As I told you, a wide operating range in terms of temperature, cold temperature as well as high temperature. Finally, you have to start worrying about toxicity. Once the battery is used and it is disposed of, is it going to be a toxic waste? And how is it going to be disposed of? Another important parameter that one has to worry about is whether it allows fast charging. Not all batteries will allow fast charging. Will I be able to charge in 10 minutes, 15 minutes, half an hour? Or will I be able to charge only in several hours? Most battery best charge in 3 to 4 hours. But will I be able to charge fast when required? Plus low self-discharge. Next slide, please. So given this, next slide, please. Yes. Given this, historically, and can you turn? Yeah. Historically, these have been the battery. Lead acid, nickel cadmium, these were all rechargeable battery. They came in about 30 years back, and nickel metal hydride. If you look at it in terms of watt hour per kg, they are all low. And then came lithium ion battery, which is, and there are different versions of that, 250 watt hour per kg. And in fact, today it touches 300 watt hour per kg. In fact, this makes this battery extremely usable. And even though out here I have put a 500 to 1000 cycles or 2000 cycles, today you can fairly easily get batteries with 1500, 2000, 2500 cycles. So these are the batteries, and definitely lithium ion has become the battery of choice. Next slide, please. And next slide. The reason it has become a battery of choice is because its energy density is very, very good, 250 to 300 watt hour per kg. Now, if you notice out here, you find that as the energy density has kept on going off from 80 to 140 to 220 to 310 over the last decade, the prices per kilowatt hour has fallen from $800 to 110. So as it continues to go up, because you will require less amount of materials per watt hour or kilowatt hour. As you require less amount of material per kilowatt hour, your prices will continue to go down. Of course, higher energy density has a safety concern. But I think petrol, when it was first used, was very unsafe. But we have learned to use it safely. So it's a question of learning to use a battery safely. And as I pointed out, cost of battery is inversely proportional to energy density. So as energy density keeps on increasing, we will keep on getting lower and lower cost battery, which is critical. Next slide, please. You can go to the next now. Yeah. Any new batteries that will come tomorrow has to compete with existing cell in terms of, as I told you, energy density, in terms of cost, number of cycles, and temperature range. Today, the batteries that are just coming in are still lithium-ion batteries with nickel-rich cathode and silica anode. These two things are taking the energy density up from around 200 watt hour per kg to 300 watt hour per kg, and tomorrow you may get a 400 watt hour per kg. Tomorrow, better battery can come. Lithium polymer, solid electrolyte, lithium sulfur, lithium ion. But as I pointed out, they have to all compete with the existing battery in terms of energy density, cost, number of cycles, and temperature range. Let's go to the next slide and see how the new batteries that are emerging are showing up. The promising batteries for tomorrow are lithium air. The reason lithium air is extremely interesting is it has a extremely high energy density, 13 kilowatt hour per kg. So it is a 13,000 watt hour per kg. It's in fact higher than petrol, but its number of cycles today is very low. When will this battery be available? It's totally unknown. I would not say that this will be available in next 10 years. Lithium metal is a little more likely to be available in 5 to 7 years. If you see, this has a 300 watt hour per kg. Number of cycles are also good. One of the good part about this battery is rapid charge, but it's still safety is a big problem, and there is dendrite growth that takes place which shorts the battery. I think it's a 5 to 7 years before we can see this. There's a lot of talk about solid state lithium. It has a decent energy density, it has a rapid charge, but it has a poor conductivity when it is cold, and its life cycles are also very low, at least 5 years away, maybe longer. Lithium sulfur is another promising 500 watt hour per kg, but look at the life cycle, it is even poor. And same is with sodium ion battery, worse energy density and low life cycle. So even though they are all promising, and you keep on reading in the newspaper that they are solid state lithium batteries will come, I think it is still 5 to 7 years away. Next slide, please. Next, yeah. So as I pointed out, we have these as there. 5 to 7 years down the line, some of them may turn up to be good, and probably 10, 12 years down the line, some others may. But actually, in terms of what it looks and feels for a cell, will be very similar to current lithium ion battery. So even if these things come and become better battery, making a battery pack will be very similar exercise. Next slide, please. Then there are other alternatives, and you also hear occasional talk about it. For example, flow battery, long life, but very high capital cost. It may be usable for fixed applications in countries where interest rate is low, where interest rates are 2%. But where interest rate is 10% and 12%, the initial cost is so high that yearly cost will be so much that even though the life is long, your interest rate itself will keep killing you. Another very promising, all the time talked about, is hydrogen and fuel cells. They exist, very costly today. Whether 7 years down the line, can they be more cost comparable? Hopefully. We keep on hearing about it, and every year its availability and usefulness in terms of cost and other things gets postponed by a year. Supercapacitor is another promising thing, but again, very expensive per watt hour. Next slide, please. So as I pointed out, these are all promising future. Maybe we may see flow battery for fixed application, for electric vehicles, unlikely. Next slide, please. So to sum up, lithium ion batteries with its high specific energy, low cost, and decent life cycle is here to stay as a primary electric vehicle for quite some time. Currently, it is NMC and NCA will keep improving. You will see some early gain with silica and anode and nickel-rich cathode. That's already happening. This will keep on improving, 300 to 400 to 500 watt-hour per kg. Beyond that, you will see versions of lithium-ion batteries emerge, like lithium metal, solid state, in 7 years time frame. And still others can appear for stationary applications. Next slide, please. So what impacts the life of lithium-ion battery cells? This is a very important thing because after some time you have to replace them. The cycle life of a battery cell depends on what is called C rate, charging rate and discharging rate. Very often talk is done that my vehicle can get charged in 15 minutes, 20 minutes. Well, you need then the battery, which are expensive, which can charge at this fast rate and still not impact the life cycle. You may initially buy a battery which may be promised to give you 5 years or 6 years, and you start doing fast charging. It may not even last beyond 1.5 years, 2 years. So you have to worry about the C rate. There are cells which allows faster charging, but then you have to select those cells and they're expensive. Temperature of its charging and discharging. It's important because the lithium battery behaves best at 25 degrees centigrade. Above 35, it is not good. At 45, it is poor. Similarly, below 15 degrees centigrade, it is not good. At 5 degrees centigrade, it is poor. So temperature of charging, discharging will play a very important role. And then a parameter that is a design parameter, how much are you going to discharge and how much are you going to fully charge, which is called 100% charging. You normally don't do 100% charging. You don't do 0% discharge till 0%. You typically discharge between 85 and 5%. So this is called depth of discharge. And if you, life depends critically on depth of discharge. If you try to charge it fully or discharge it fully, your life gets impacted. Now, this is something that is not well understood. And this is what I am pointing out. Best used at 25 degrees centigrade. Best charging rate is in what is called 0.1 C in about 10 hours, or at least in 4 or 5 hours. And best is that you operate between 10% and 80%. You may not be able to do it all the time, but keep this, that this is the ideal. Otherwise, your life will go down. Next slide. So, what are the factors influencing? As I pointed out, the manufacturer may say it is 1,000 cycle, but the 1,000 cycle will be such that it has to be charged at 2 hours at a 25 degrees centigrade and 85% depth of discharge. You try to charge at higher C rate. That means in half an hour, 15 minutes, and the number of life cycles goes down like anything. Similarly, you try to discharge at fast, your number of life cycles deteriorate like anything. And remember that after it deteriorates to 80%, its range gets affected, and therefore the battery becomes unusable for the car or electric vehicle. Next slide, please. Similarly, as I pointed out, the best window for charging, discharging is 25 degree plus minus 5. Above 30, it is bad. Below 20, it is bad. And that's what this curve shows. And for a larger vehicle, you can cool the battery and ensure that it works in this. For smaller vehicle, you cannot cool it. For example, for two-wheeler, you cannot cool it. And therefore, it becomes a challenge that how do you design the battery? Next slide, please. And as I told you, depth of discharge. If you put 100% depth of discharge, number of cycles goes down. If you put 80%, number of cycles goes up like anything. And there also it depends whether you use top window, bottom window, or middle window. I'm not going to get into this. Best is between 5 to 85 or 10 and 80%. Next slide, please. So, you initially use the battery, but once it becomes 70% or 80% of initial capacity, then you will not continue to use it in a vehicle because your range will go down by 70 to by 25 to 30%. And range is a very, very important parameter for a vehicle will stop after that range, so you will replace that battery at maybe 80%, sometimes 70%. And you can always use it for fixed storage, however, because fixed storage, even though size is bigger, weight is higher, probably does not matter. And that's a second life of the battery. After the second life of the battery, basically you have to recycle the battery, and you need to recycle with near zero effluent. Today you do it with electronic gadgets, for batteries for electronic gadgets, for smartphones, laptop batteries, they're all lithium ion batteries. Today there is plenty available for recycling. Tomorrow electric vehicle batteries will be available for recycling. Next slide, please. Okay, if you look at it, actually the main materials that is used for these batteries is lithium, cobalt, manganese, nickel, and graphite. And unfortunately, we do not have much of a deposit of lithium, cobalt, manganese, nickel, and graphite. And our import bill is likely to go up like anything, because we are likely to import over 25 gigawatt hour by 2025. In fact, more. I'll say by 2025, you are likely to hit about 35 gigawatt hour and probably reach 100 gigawatt hour by 2030. What is the option for us? Option for us is to take used battery. Today, the cell phone and laptop battery, tomorrow the car battery, and recover the material, recycle the material. And it is possible today using particularly hydrometallurgical recycling process with near zero effluent, not zero completely, but near zero effluent. And you can recover 90% of lithium, cobalt, nickel, manganese, and graphite, and then you can reuse it. This is a very, very important technology. I had actually once talked to Tata Steel about it, that this is a technology in which India must become the best in the world. In fact, India should become urban mining capital of the world. Not only it should recycle its old battery, it should also bring battery waste from other countries and recycle this. You must recycle with near zero effluent, otherwise nobody will allow you to import the West. But if you are able to get to near zero effluent and recycle well, you will be able to get there. Next slide, please. So what is involved when you take a battery cell, individual battery cells, and make a battery pack? There are actually 3 steps. The first step is, how do you make battery cell? First is the material, next is the cell, and third is the battery pack. What is a battery pack? Very often people think, oh, you can just assemble the battery cells and it becomes a battery pack. You will soon see that this is not really true. In fact, particularly for India, where the temperatures very often go to 45 degrees centigrade, battery pack requires a very, very careful, one of the best thermal design. Some of the best thermal engineering is required to ensure that battery temperature stays as close to 25 degrees centigrade as possible. Similarly, you need a very good mechanical design, particularly if these batteries are cells put together. The cells, in fact, if you put too much of pressure around the cells, the life cycle gets deteriorated. If you put too little pressure, then they will bulge out and life cycles get deteriorated. So you have to have the right pressure on each of the several hundred cells that goes on to make a battery. And you know, in India, when the vehicles travel on the road, there is a lot of vibrations and things like that. So mechanical design of a battery pack becomes very critical. And in fact, the life can significantly deteriorate without a careful mechanical design. And equally important is a very, very careful electrical design. We are talking about currents of the order of 200 amperes or more. Even if there are 2 paths for the current to flow, and if the paths are even 1 milliohm difference, 200 volts, 200 ampere square into 1 milliohm gives you a lot of losses. You have to be very, very careful, and it hurts the battery pack because it will become unbalanced. Similarly, you have to have a very good battery management system. Very often people keep on talking about BMS is the key. In fact, I will say BMS is less important than the thermal design, mechanical design, electrical design. But BMS is important because it manages two things. First, safety, and second, the life. Life particularly in balancing, in cell balancing. And this is very often ignored. It is about 35 to even sometimes 40% of value add for a battery from cell to pack. Then there is a cell chemistry. This is about 25% value add. Now, this is cell design is very much like a chemical plant. If you run a chemical plant, you can actually run a cell manufacturing. The problem with cell manufacturing is its technology keeps changing every 1.5 to 2 years. In fact, that is the one which brings the cost down because you now need less material for the same watt hour. And if you do not just have today's technology, a year and a half it will take to set up the plant. And by the time you make your plant work well, your cells will become obsolete. So this is something continuously evolving. That is what makes it challenging, very much like your integrated circuit. And then, of course, there is materials. I talked about it: lithium, manganese, cobalt, nickel, and graphite. And this is the primary cost, 40%. And if we don't have it, the only way we can do is recycle. Next slide. So thermal design, as I told you, is must to remove heat. Mechanical design should be include safety concerns, right pressure. Electrical design to ensure equal drop, and BMS will ensure that all cells are balanced, and they basically make the whole thing safe. You also say BMS will have a communication with the charger, communication with any IoT device and all that. Next slide, please. So battery pack manufacturing actually involves a very, very large number of components. Like just click it once again. Large number of jobs it will give you. It has a very large number of components. Each individual component has to be very carefully used, because if it is not used carefully, you will not get the performance. Next slide, please. And finally, I want to end by saying India needs a state-of-art cell manufacturing. It drives costs down every year. Recent Government of India incentives, they have this production links incentives, is good, but it has some lacunas in the sense that the way it has done it is for large company only. I wish it had allowed small companies so that we have 20-30 different technologies that would have come in, because as I told you, new technologies will evolve almost every year. Cell to pack manufacturing, this is something India is already doing well, and there are a lot of startups which have learned to do this well, including several at IIT Madras. And of course, zero-effluent recycling. This is very near zero-effluent recycling, very, very critical. And once again, there are companies at IIT Madras which are doing this. This is all that I have, and I can now take questions and answers.
Thank you, Professor, for that enlightening address, and also helping us really understand the batteries all the way from the basics into the recycling and the manufacturing aspects. So if you're good, maybe we could take a few questions that have come in from the participants. Okay. The first one, I think you have kind of addressed it, but I will still go with it. There's a question which is around the battery material scarcity and the availability of battery materials only in a few locations globally.
Yes, I've already answered that. The best way is to recycle. Recycle. You start doing it today, you have huge, there are 300 million cell phones thrown away every year. You have these batteries, they're small in size, but significant amount of materials. Okay.
All right.
And this is one technology. This is not an easy technology. You can easily get a technology which is polluting. You can easily get a technology where you recover 70 to 80% of the materials. But the key thing is to recover 90, 92, 93% and not to have any effluents.
That's right. And for a country like India, I think that might be the key to success as far as battery manufacturing is concerned.
Yeah, and a new production link incentives is likely to be announced by Government of India. There is a committee. I am a part of that committee working on it.
Yeah. So on the same, around the same topic, Professor, there was also another question or another comment. In terms of, if you could enlighten the audience in terms of the kind of research and the exploratory work or industrial work that is happening in the battery space, anything that you might want to further add for the benefit of the audience, and how do you see, given all the incentives that are coming from the government, the battery manufacturing? Do you see a gigafactory coming up anytime soon in India?
So again, let's talk about different things. If you are talking about cell manufacturing, yes, you are likely to see gigafactories coming up. That incentives have been, that will be largely not with Indian technology. You will have to pretty much tie up internationally, because today the best technology that we have actually gives you 120, 130 watt hour per kg. Internationally, people are crossing 300 watt hour per kg. And therefore, there is a production linked incentive that is likely to go for tendering soon, and we will see cell manufacturing happening. But far more important is cell to pack. Now, this is where you will see huge amount of work going on in India. Already started. There are a number of very good startups. Most people do not understand cell to pack manufacturing. They think it is assembling work. They do not know how to do good thermal design. They do not know how to do good mechanical design. In fact, most people fail to do good mechanical design. Electrical design, they don't even understand. I pointed out 200 amperes flowing into 1 milliohm difference. What does it really mean? Most people don't understand. And even if they tie up with outside, who has made batteries work at 40, 45 degrees centigrade? In Germany, people are quite happy if it works up to 35. In China, it works up to 35. In Japan, they don't have 45, 48 degrees centigrade. So they don't even have, the affordability in India is low. So all these things will require India-specific design. And unfortunately, most large companies are foolish, and I'm basically will tell that they're foolish to sort of say, oh, we will tie up and get the technology and we'll make. Well, they'll do it. After a few years, they will get hit and realize that, and then they will start doing R&D. But there are several good startups, good labs. For example, IIT Madras, our Center for Battery Engineering Electric Vehicles, is one of the best battery R&D house. We have designed so many batteries, and still we have made so many mistakes. If I look the battery that we designed 4 years back, I mean, frankly speaking, they sucked. There is a huge learning that is required, and learning is not possible without burning your hands, because what happens at 45 degrees and 40 degrees centigrade is not well understood.
Thank you for your, for all those points. I think they have been quite, blunt in what you are saying. And I hope a number of people who are in this space take your points of view, and hopefully as a country, we can make something, or we can have some change.
It's a question of whether we'll win in 2 years or 6 years.
Yes, I think that's the positive outcome of this conversation. So thank you. So let's move on a little bit. There's one question that has come up from one of our participants, which is a little away from the lithium-ion batteries and the other batteries that you've been talking about. This is on quantum batteries. He wants to know your views, your thoughts on quantum batteries, and do you think
more than 10 years away? It is more than 10 years away. More than 10 years away.
Okay, but you see some progress happening in that space.
Very good research topic, very good area. I have pointed out to you which are the batteries for the next 5 years. There are a lot of potential between 5 to 10 years, solid state lithium and others. The batteries like quantum chemistry is at least more than 10 years away. So it may be more. In fact, several experts probably say that the current lithium ion batteries are likely to be remain the dominant battery for 15 years.
Right. Thank you,
I don't
Prof.
want to say that, but 10 years at least, you won't see anything much.
Okay. So thank you. There's one other question or comment, and seeking your views on that. You mentioned in your presentation the upcoming technologies, battery technologies, but at the same time, on lithium-ion batteries, which are the go-to batteries at this point in time, there have been reports saying that we have kind of reached the plateau in terms of development. There have been reports from MIT, for example, which says that further developments in lithium-ion batteries are hard to come by. But at the same time, we also see costs going down from the current $100 per kilowatt hour down to maybe 60, 80. That's what
So I think
Bloomberg and others are predicting. Your views?
reports are not correct. I will say by and large, they talk in terms of fundamentally, probably nothing much can be done. But let me tell you that the work that is done with putting silicon in anode is a very, very complex work. And similar thing is in high nickel cathode. There is a lot of work going on. As I told you, over the next few years, you will see 400 and 500. That's where the cost will come down probably to $80 per kilowatt hour. I don't know whether they can come down to 60, but I won't rule it out. 60. Beyond that, it will be at least 5 years away. And that's where you will start probably seeing either a solid state lithium ion battery or something like that. But there are also lithium ion batteries. As I pointed out, there are the other batteries, advanced batteries that people have started talking. You occasionally see things coming out from labs. But in terms of what will be their cost, will anyone be even $150 per kilowatt hour? No way. Not for 10 years. Then why will people use it? When the battery available is $80 per kilowatt hour, cells available are at that price. So that's what people don't understand. The current lithium ion batteries have been there for more than 10 years, but their costs were very high, $1,000, and it took 10 years for it to come down to that kind of price. Similarly, any other kind of battery will also take 10 years after they are mature for them to come down on the prices.
Right, thanks. But the journey or the improvements that we have seen in the lithium-ion batteries over the last 10 years, 4 times increase in energy density and almost 10 times drop in costs is an incredible
You will see
achievement.
at least 3 times in the next 7 years.
Yeah. So since we spoke about, and since this is a technical question, we spoke about solid state batteries, and you said it is still out in the about 10 years out.
Years, I will say you may see early 6 years down the line.
All right.
I'm talking about cost. If you're talking about experimental battery, R&D battery, plenty is available even now. In terms of cost competitive, $100, $80 per kilowatt hour, at least 6-7 years out.
Okay. So this question is more on the problem of dendrites that we see in solid state. And this question is, are we seeing some really clear solutions in solving the problem of dendrites? And then are these solid state batteries really scalable for manufacturing the way lithium-ion batteries have been manufactured?
Yes. So if you see every few months, the problem of dendrite is attacked and the solution comes that much closer. So I think it will take 3 to 4 years more. That's my estimate before the problem is solved to a reasonable extent. It is at this point of time you really start seeing trying to optimize cost. And my feeling is it will take 3 to 4 years.
Okay.
Beyond that. So 7 years is what my estimate is. I may be wrong. Instead of 7, it may come in 6, but it is not. I'm not order of magnitude wrong. But 7 can become 8, 9. I don't rule that out.
Okay, thank you. I think that helps. That helps. So we're going to be seeing significant improvements, not only in lithium batteries, maybe not so much in fundamental improvements, but cost improvements in lithium and also other batteries over the next decade. So the batteries seem to be in a good place going ahead. There's one other question, and this is probably from somebody who is in the business of manufacturing, wants to ask you about opportunities where small scale industries can get into battery or accessory manufacturing. And then there is a specific mention of the investment, and the person talks about an investment of 1 million to 10 million Indian rupees, or 10 lakhs to 10 crores of investment. Any thoughts on that, Professor?
10 lakhs getting into battery manufacturing, even pack manufacturing, is totally unlikely. 10 crore, maybe one can get into pack manufacturing, but I still feel that even with 10 crores, you will not get to the scale that is required, and maybe early initial investment of 10 crores, but eventually you will need to get to at least 100 crores. Otherwise, the cells that you purchase or the components that you purchase itself will be too expensive. Unless you are buying at a volumes of 50,000 pieces, your input cost is not good enough, is high. You get killed by the input cost. So starting with 10 crores, moving up to 100 crore is the kind of investment required for cell to pack. Cell manufacturing is 500 crore rupees investment, or even higher, 500, minimum 500 crores. The recycling, I don't know. We still haven't figured out. There may be a medium opportunity with a 5 to 10 crore. You may be able to set up a small plant. Of course, large plant will take a large cost. Other accessories like chargers and other things, sure, there are plenty of opportunity for manufacturing this. Motors and controllers, sure, with 10 crore investment, you can get into it. But then you need the right technology, and you won't easily get the right technology. If you go for technology like German technology, they will be very good technology. They will be just too expensive, will not sell in India. If you try to take Chinese technology, very poor quality technology you will get, unless you are very, very lucky. So that's where you need something in between, and that's where Indian R&D becomes very, very important. I think motor and controller is a very large opportunity. That will also require all kinds of material. We didn't even talk about the materials required for electric motors. That I did not talk about. One could have talked about it, but this was focused on battery.
That's right. Yes, on electric motors and the non-grain oriented steel, etc., is another topic of discussion. Yeah. So, Professor, I think these were some of the questions the audience had put out to you. I don't think we have any more questions as such for you. Any other closing comments you might want?
No, thank you. And I leave the studio now.
Thank you very much, Professor, for that really enlightening lecture, so to speak. It really helped all of us to take away something in the space, and it gives us the confidence that, batteries as a fundamental element of future mobility is here to stay. And hopefully India will also make its mark in manufacturing and design, manufacturing and research of batteries. Thank you once again for joining us.
Anybody
really
wants
appreciate taking
my
the time.
Presentation, please write to me at ashok@tenet.res.in. I have typed it here. Please type it in the window for everybody who are watching. Anybody can write to me, and I will send them the slides, not in PPT form. I'll send them in the PDF form. I will be happy to questions also.
Thank you, Professor. Thank you for that.